questions. Our essential questions are: where do significant figures come from, and how do you know how many significant figures you have? Okay, so significant figures. These are all the numbers in a measurement that are known with certainty plus one that is estimated, and this comes from measurement. So if we look at this picture of a nail and we look at the ruler, we can say for sure that it is in between 6 and 7 centimeters. So we know it's 6 something for sure. And if we look a little bit closer at this zoom in, we can see that it is between the 3rd and 4th mark. So it's either 6.3 or 6.4. It's somewhere in between there. So we know that for sure as well. Then what we're going to do at 6.3 and 6.4 is we're going to add one digit that is a guess, an uncertain digit. So it looks about halfway through. So we're going to call that 6.3. We know those for sure. And then we're going to add a 5 there. Okay, so that is 3 significant figures. We wouldn't want to put 6.3500 because those zeros say that we think it's more definite than it is. Okay, so just the 6.35. So that is incorrect. All right, so the rules for determining which numbers in a measurement are significant figures. This first one is the easiest one. Any number that's not 0 counts as significant figures. So what we're doing here is just counting numbers. So 213.5, there are 4 numbers there, so it has 4 significant digits. 12,567 have 5 numbers there, so that's 5 significant digits. Okay, so that's the first rule, and that one's pretty straightforward. The rest of the rules have to do with the zeros. So the second rule is that zeros that are sandwiched or between non-zero numbers are significant figures. So on 205 grams, that 0 is in between 2 non-zeros, so it counts. So that would be 3 numbers we're counting there as significant figures. Okay, then 10.0002 grams, that is also, all those zeros have been sandwiched. Okay, they don't have to be right next to the numbers as long as they're in between some. So we're going to count each and every number there. So that would be 6 significant figures. Okay, the third rule is also with zeros. It's to the left of the number are not significant figures. Now they have to be there because they are placeholders, but they are not considered significant figures when we're counting those. So 0.078, we're not going to count the zeros, only the 7 and the 8. So that gives us a significant figure number of 2. 0.00005, we're not going to count any of those zeros that are to the left of the number, so we're only counting the 5. So we have 1 significant figure there. Okay, number 4, zeros to the right of the number and to the right of the decimal are significant figures. So if there is a decimal and they're to the right, they count. So 2.00, those are all going to count, so we're going to have 3 significant figures. Okay, this next one, 0.00100. The ones to the left of the 1 do not count. They are placeholders, but they do not count. The ones to the right of the 1 do count. So we have the 1 and then the 2 zeros to the right, which is 3 significant figures. Okay, zeros at the end of a number are not significant unless there is a decimal point. Okay, they are just placeholders. So this first example with 1200, we don't know if we're rounding, how close we're rounding, so that's not significant because there is no decimal point. So we're only going to count the 1 and the 2. So that will be 2 significant figures. However, the next problem here, 1200 with a decimal, is saying that I am very sure. Okay, so that those zeros do count in that case. So that is going to be all 4 numbers counting. Really the easiest thing is this exponential form. We look only at the coefficient, not the exponent. So if it says 4.50 times 10 to the 8th, we ignore the 10 to the 8th, and we just look at what is in the coefficient, and that's 4.50. That's 3 different numbers. So that has 3 significant figures. Okay, so we're going to practice. What I'd like you to do is go ahead and pause the video and go through this and just guess, and then you can check it with me when you're done. So just push play when you're finished. All right, 250. Okay, there is no decimal point, so that doesn't count, just the 2 and the 5. 35029. Okay, the 0 is sandwiched, so every number counts there, so that's 5. Number 3, the numbers are to the zeros are to the left of the numbers, so they don't count, they're just placeholders. So we're just counting the 7 and the 5, which is 2. Number 4, there's no decimal there, so we're only counting the 9. So that was 1. Number 5, Okay, the ones to the left of the 8 don't count, they're just placeholders. But because there's a decimal point, the one to the right of the 8 does. So that we have the 8 and the last 0 counting, so that gives us 2. Number 6, we have a decimal point, so everything counts. So that would be 4 numbers. Number 7, we just have to count the coefficient, so that's the 3 and the 6. So just 2 numbers there. Number 8, there's no decimal point, so we're only counting the non-zeros, which is the 1 and the 5. So we get 2 numbers there. Number 9, we have no zeros, so each number counts. We have 5 numbers present. Number 10, we have a decimal point, so all of those zeros count, and so we have 3 numbers there in the coefficient. Number 11, the zeros to the left don't ever count, remember that. Okay, but we have a decimal, so the other ones do. So we have 6 and then 3 zeros following it, so that gives us 4 numbers. Number 12, there is a decimal, so all the numbers count. So we have 2 numbers there. 13, we have no decimal, so those 2 zeros are placeholders. So we are just going to count the 4 and the 5 to give us 2. Number 14, numbers to the zeros to the left of the numbers don't count, so we're just counting the 2. So we have 1 number there. And then number 15, we have a decimal point, and they're to the right, so we are going to count every number. We have 4 numbers there. The last thing we're going to talk about here is rounding off numbers. I know you've been doing rounding numbers since you were in elementary school, so this is just going to have to start counting from the first significant figure, and we start counting from the left, okay? If we have zeros on the left, we don't count those. So if we look at the first one, it says round 65.31890 to 3 significant figures. So first I'm going to draw my line. I'm looking for the first 3 numbers, so I have 6, 5, and 3, and I'm going to drop off everything after that. Okay, then I'm going to look at the next number, which is a 1, so I round down. So that's just going to be 65.3. Okay, next one we have 0.05981. Okay, 3 significant figures. We're skipping the zeros and we start with the 5. So we have 598, and I'm going to draw the line right there. And I look at the 1, and it's going to let me round down. So I need to include those zeros in my answer because they are placeholders. 0.0598. Okay, the next one, we're 2 significant figures. So we have the 4 and the 3, and then we're going to stop after that. We look at that next number, which is a 9, and 9, of course, is going to cause us to round up. So we end up with 44, but we need to fill all those placeholders because 43,925 does not round to 44. It rounds to 44,000. Okay, so that's something that students do a lot, is that they just stop the number right there. You need to replace those other numbers with zeros as placeholders. Okay, 545,858. We have 4 significant figures, so I'm going to go 5, 4, 5, 8 and draw my line. Okay, since it's a 5 after that, we're going to round up. So again, it doesn't round to 5,400. We need to replace those numbers with zeros. So 545,900, or I've given it to you in scientific notation also. Okay, when you have scientific notation, we're doing 2 significant figures. So I have 9.9992. So I'm going to do 9.9 and draw my line. Well, that's going to round up to 10. When it rounds up to 10, we can't have that. So we're going to move that decimal over 1 like we learned to in scientific notation. And we get 1.0 times 10 to the negative 3. But I'm still keeping in line with having 2 significant figures.